The tool is located in the Shapes group of the Model tab in the Sweep Types drop-down list. After the helical sweep dashboard opens, open the References tab and click Define to begin sketching the profile of the spring. In this example, we're going to sketch the spring's profile on the front datum plane in a 2D orientation. The spring center line is the first entity we'll define. This will be the center axis of the spring, the axis of revolution. A vertical line to the left of the center line will represent the profile of the spring. This will be the diameter of the spring defined through the center of the spring's wire. Next, define the diameter and height. The diameter of the wire will be sketched at the start point of the profile using a circle, but you can use any shape you need. The helical sweep dashboard makes it easy to edit the pitch value of the spring as well as toggle the spring from a right-hand to left-hand turn. To finish the spring, however, we want to make sure the spring maintains 6 coils no matter how much it's expanded or compressed. To do this, we'll need to add a relation to the part. This relation will be used to control the spring's pitch as it expands and contracts. Go to the Tools tab and open the Relations dialog box. We can see that the height of the spring is D1, the pitch is D2, and the diameter of the spring is D0. We need to write a relation that says the pitch, D2, equals the height of the profile, D1, divided by 6. This will ensure that the spring will always have 6 coils. There. Now we can test it by editing the height dimension to compress and expand the spring. The helical sweep tool and its dashboard interface is a powerful combination that makes creating any spring in Creo Parametric quick and easy.
The first step is to create the new drawing file. So first I'm going to click on the New button in the corner, and I'm going to select Drawing and press OK. Now a dialog box is going to open and it's going to ask me for the default model. So I'm going to click on Browse, and I'm going to choose the drawing.part, and I'm going to leave the template as a C, and I'm going to press OK. The first thing I'm going to show you is how to move a part by clicking and dragging on it. So the first step is to highlight the part you want to move, then right click and uncheck Lock View Movement. Now when my cursor is over it, I can click on it and you can see I can move my feature wherever I want. Also notice that the other two features are going to stay in line with this feature regardless of where I move it. Another way of moving is by first highlighting the object you want to move, then right clicking and selecting Properties, and then in the Categories tab, click on Origin, and you could change the X and Y locations of that drawing view. So I'm going to change these values so that the X and Y locations are both going to be 5. And these measurements are going from the bottom left corner of the sheet to the center of that drawing view. And I'm going to click Apply. Another thing you can do while in the Properties tab is to change the view orientation. To do this, click on View Type, and then where it says Model View Names, I'm going to change it to Bottom and click Apply. Note that a dialog box is going to appear, and it's going to inform you that the other two views are also going to change because you reoriented this one. So just click Yes, and notice how the drawing changed. To add a projection view, click on Projection in the Model Views tab, then click on the view you wish to add the projection to, and then click where you want to add the projection. Notice that right now it's currently a shaded view and I want this to be hidden, so I'm going to right click and select Properties, and I'm going to click on View Display, and I'm going to change the display style from Follow Environment to Hidden. Now I'm going to click Apply and Close. To change the scale, click on any of the projections, then right-click and select Properties, then click on Scale in the Categories tab, and select Custom Scale, and I'm just going to make this 0.05, and click Apply. Notice that when you change the scale, a scale note is going to be created. I'm just going to move this note down into the corner. Now I want to add a general view to my drawing, so I'm going to click on General, and I'm going to click Default and press OK. And now I'm going to click where I want the general view to be, so I'm going to click in this empty corner over here. Now let me just move this dialog box so you can see the general view. Right now the model is set to default orientation, and you could change the default orientation from trimetric to isometric or user defined, but I'm just going to leave it as trimetric and click Apply and press Close. With general views, it is often okay to leave it as a shaded view, unlike when creating a projected view, you want it to be hidden. I'm going to create an assembly drawing that will use balloons to reference the parts in the assembly to the bill of materials. The first step is to click on the Table tab, then select the table icon, click on Quick Tables, and choose BOM Description Down. Now you're going to be prompted on where you want to place it. I'm going to place it in this bottom right hand corner. Now I'm going to make the corresponding balloons, and there are a few different ways to do this. One way is by clicking on Create Balloons and selecting Create Balloons All. This will create balloons only on the main view that the projections stem from. You can move the positions of balloons by first highlighting them and then clicking on the white boxes. And also notice that when one balloon is highlighted, it is also highlighted in the bill of materials, and vice versa. To clear balloons, click on the Balloons tab and select Clear Region, and then choose Yes. You can also create balloons based on a view. To do this, click on Create Balloons and select Create Balloons by View, then click on the view you want to create the balloons on. I'm going to choose this projection. And again, to get rid of the balloons, I'm going to click on the Balloons tab and click Clear Region and choose Yes. Now lastly, I will create balloons by component. So first I'm going to click on Create Balloons. Now I'm going to say Create Balloons by Component. And now you can select one or more items. So I'm just going to first select this plow, then click down on the scroll wheel, and notice that the balloon was created. Now I'm going to do this again, and I'm going to do multiple items. Now I'm going to create the balloons by component one more time, but this time I'm going to select the references on the model tree. And now press the scroll wheel, and all the balloons are created. Now I want to clean up the way the balloons look, so first I'm going to highlight all of the balloons by clicking on them and holding Control. And then I'm going to click Clean Up Balloons. Now I'm going to change the offset from View Outline from 0.8 to 1. And I'm going to check the box where it says Create Corresponding Snap Lines, because I find it makes fixing the balloons easier. And now you can preview what it's going to look like. And I'm going to press OK. Clean Up Balloons does a nice job, but it isn't perfect. Notice how balloon number 11 is going across the entire assembly to this bottom line. I'm just going to highlight it and then move it so that it's on the top line. Another thing to keep in mind when making balloons is that you shouldn't have any of the leaders cross each other. It's typically just bad convention to do so, so try and avoid it. And now I'm just going to get rid of these construction lines. Press delete, and there you have our
An auxiliary view is a type of projection view that is projected at a right angle from a selected surface or normal to a selected axis. To create an auxiliary view that is projected from this view so that this circular surface and its pattern of 6 holes are displayed parallel to the drawing sheet, click Auxiliary from the Model Views group. If the selected direction reference is an edge, surface, or datum plane, then the view is projected at a right angle to the reference. This means this edge can be selected as the direction reference for this view. Then click to place the view. Another way to get the same view is to click Auxiliary and select this axis as the direction reference. If an axis is used as the direction reference, the view is projected normal to the axis. Properties of this view, we can see that the view type is auxiliary. The parent view is named General View, and the projection reference is a datum axis. Also notice that the projection arrows option is set to none. Change this to single and click Apply to see a single projection arrow added to the drawing. Change the option to double and click OK to add a double arrow projection